You're good. You pick up the dust.
So yeah, as my advisor said, these are iRobot crates. They are for research purposes, the same as room was that just they don't have vacuum cooling property. So we can program them, send commands to our computers, and we just like bring this together with controller and robot computer. So it'll be fun. If you want to use it, it works like joystick. You just need to push A.
Control the people on your side.
So you can. So this is just something that we did for fun, but what we do for research is, my advisor talked about it a little. So we are trying to get help from robots for environmental monitoring. For environmental monitoring, we use these small devices. These are simply, you can think that very small computers. They have processor, they have a memory, they also have some onboard sensors, and also they have communication capability. They have a wireless antenna. They work very similar to computers, but the thing is they consume less energy, so their computing power is less. And as you say, they work with two AA batteries. With two AA batteries, these devices can work more than a year if you can use them efficiently. So this is what we want to do. We get help from robots to extend the life of these robots. How we extend it is we go nearby the sensor to collect the data, and and we want to do this autonomously with the robot. So now what I'm going to show is I will put this sensor somewhere, and we'll hopefully see that the robot will find a good location to download the data. And for good location, what I mean is, imagine that this is a wireless router in your house, and you are in your bedroom, and you move your laptop a little, and the signal strength will drop, right? So your internet connection will start to drop down. So this radio signals are very unexpected. It's not like just distance, but also orientation may affect. And also, even if you, for example, get closer, the signal strength may drop because of several effects. You can imagine signal strengths as waves. So, like two waves can cancel each other, or they can get stronger. So, because of its nature, we cannot know like how we should go to find the good location. But we find a very simple algorithm. Basically, we put a virtual grid on this workspace, and our robot goes to each grid squares and gets samples from that, and try to find the location where it can start to download data from one. So the basic idea is, if the signal strength is good, then we can download it in a very short time. So these things will not consume too much energy, so we can extend their life.
So the same kind of effect happens with cell phones. When you emit the signal, it basically bounces around. right? And the signal sometimes cancels itself, and we all have these dead spots in our houses where nothing comes up, and you walk, take a few steps to the side, and everything is great. So the same thing is happening at a smaller scale here. The device, whenever it sends a radio signal, it bounces off from the walls, from the people, and so on. And the pattern is actually really weird. So there are some dead spots very close to the device. There are some very good spots away from the device. So the point is, the robot should be able to discover good spots by itself and download the data.
So also, it's adaptive with the environment. So if there's an obstacle,
This is a different unit completely from the other.
actually it's the same, just the laptops are different. The base is
I mean, this one was not related to that one in terms of what you were trying to demonstrate.
yeah, the function is different. So when it finds a good location, it makes a 360 turn. And after that, it starts to find a good orientation. As I told you, the orientation also affects. And after it finds the best orientation, it will go back to that orientation. And the level will be over.
So if somebody walks in between, does it change the characters?
Sure. Exactly. So for this demo, we just do the search part. So,
So it doesn't need to get any closer?
No, it
yeah. So this location was good enough to.
That's good enough for it, but
Yeah.
other ones might need to get closer.
So it depends on the threshold. The threshold that you set. For example, I don't know if it makes sense, but I put the threshold at 105, for example. And if I would say 107, let's say, then it will not be enough, so it will continue to search.
Decimal?
Sorry?
Decimal? Signal.
Yeah, so the signal strength that I'm reading from the device is between 110 and 50. So 105 is good signal strength. And as I told you, I mean, it doesn't mean that if it gets closer, the signal strength will increase. It can also drop. So it depends on the environment. If you think about water waves and think about the shape of our room, so the signals can bounce from the walls and they can cancel each other. So it is really not easy to say that this is a good location, this is a bad location. Even if it is even if it is closer because of maybe the shape of the walls close to it. In that location, the signals can cancel each other and the signal strength drops.
How often is that sending a signal? I mean, is it
So
continuous or a burst or?
We can